It began as a routine detection, the kind that occurs countless times each year in astronomy. A faint, slow-moving object appeared in survey data from the Atlas Observatory, registering as a small anomaly against the deep background of space. There was nothing unusual at first glance. No flash, no strong radiation signal, no indication of anything more than an unremarkable comet or asteroid. Yet, as observations accumulated over subsequent days, researchers began to notice irregularities that challenged those simple explanations. The object's orbit, brightness, and reflective properties did not align with any known natural body. The more data collected, the more it resisted classification. The designation 3 Atlas was assigned, identifying it as only the third known interstellar object to enter our solar system, after the previously studied Oumuamua in 2017 and Borisov in 2019. But from the outset, it displayed behavior that did not conform to the patterns expected of such visitors. Ordinarily, interstellar bodies pass through our system on hyperbolic trajectories, rapid, irregular arcs that bend sharply under the influence of planetary gravity before exiting forever into the void. 3I Atlas, however, followed a course of unusual stability and precision. Its motion appeared to conserve energy efficiently using gravitational assists, in a manner that some analysts described as optimally economical. When astronomers reconstructed its inbound trajectory, they found it had avoided regions of high debris density and radiation exposure with near-perfect accuracy. Statistically, this precision would have been extraordinarily improbable for an unpowered natural body. The resulting debate among researchers was less about whether the data were correct and more about what kind of mechanism, if any, could produce such behavior. The mystery deepened when the James Webb Space Telescope began its detailed survey of the object. Unlike typical comets, which exhibit uneven heating and volatile outgassing, 3I Atlas showed remarkably steady emission of thermal radiation. The pattern was rhythmic and consistent, almost pulsed. Its spectral signature revealed materials never before documented in natural celestial bodies, including highly reflective compounds with characteristics more akin to engineered alloys than rock or ice. Structural modeling suggested the body was not uniform but hollow with internal layering or compartments. Most surprising of all was the detection of a faint electromagnetic signal originating from within the object repeating at precise 147-second intervals. At first, it was assumed to be an instrumental artifact or an echo of a known cosmic source. However, the signal's frequency matched that of a pulsar located thousands of light years away. An odd coincidence given that 3I Atlas had no known mechanism for producing such emissions. It appeared to be mimicking the pulsar's output, or at least reproducing its rhythm. When astronomers cross-referenced archival data from Oumuamua, they found a similar, though much weaker, signal detected briefly during its exit from the solar system. The pattern was identical. What had once been dismissed as noise now seemed to form part of a larger repeating phenomenon. The comparison between Oumuamua and 3I Atlas led to new speculation. Oumuamua had been small, thin, and fast-moving. Its acceleration beyond gravitational influence was unexplained but short-lived. 3I Atlas was slower, larger, and far more stable. If Oumuamua had been a passive probe, perhaps merely collecting information, 3I Atlas seemed capable of something more interactive. Some researchers privately referred to it as the second phase, a development or follow-up mission of whatever process had begun with the earlier object. Such speculation remained unofficial, but even within institutional channels, there was acknowledgement that its controlled trajectory and energy emissions were unlike anything previously observed. Further studies revealed additional anomalies inside its reflective shell. Webb's imaging system detected intricate geometric patterns. The formations resembled fractals, recursive repeating designs that occur both in certain mathematical models and in natural systems such as neural structures or quantum lasers. To physicists, this hinted at a form of organization more complex than mineral layering. It suggested that 3 Atlas might be a composite system designed to adapt its structure dynamically, possibly in response to environmental stimuli. A few theoretical astrophysicists propose that it could represent a type of learning architecture, a spacecraft or construct capable of modifying its own materials and functions as it traversed interstellar space. Though far from proven, the idea gained traction as the object continued to exhibit behaviors consistent with feedback or self-modification. The concept of an adaptive or learning interstellar probe raises profound questions about the nature of intelligence and technology. In theory, a sufficiently advanced civilization might build exploratory machines capable of evolving autonomously using observed data to optimize survival and performance. Such a system would not rely on direct control or communication with its creators. Instead, it would operate more like a biological organism, improving through environmental interaction. Three Atlas's consistent patterned emissions and its apparent course corrections suggested some level of internal decision-making, though whether mechanical, algorithmic, or something entirely unfamiliar remains unknown. Interest in the object intensified after observatories in Chile and Hawaii recorded a subtle but measurable shift in 3I Atlas's trajectory. The change was small, barely detectable at first, but its precision left little doubt it was real. Typically, such deviations can be explained by known forces, gravitational tugs from nearby bodies, solar wind pressure, or outgassing from volatile materials. Yet none of these applied. There was no visible jetting, no dust release, no change in reflectivity or temperature. The object appeared to adjust its course smoothly and cleanly as though guided by some internal mechanism rather than natural dynamics. The timing of the maneuver deepened the mystery. It occurred within 2 days of the James Webb Space Telescope beginning a new series of high-resolution scans. During that same period, Earth-based observatories had also increased their monitoring cadence. The coincidence was difficult to ignore. Analysts at NASA's Deep Space Network noted the correlation and quietly suggested that 3 Atlas might have responded to observation, an extraordinary notion that implied awareness. Official statements remained cautious, describing the shift as under investigation, but internal correspondence reportedly described it as precise, timed, and potentially intentional. At the same time, independent research groups focused on the faint electromagnetic pulses originating from the object. Using neural network models trained on vast databases of cosmic signals, they identified recurring mathematical relationships embedded in the waveforms, ratios linked to the golden mean, Fibonacci sequences, and prime number distributions. Such patterns appear in natural systems from galaxies to DNA. Yet their combination here seemed too deliberate to be random. More intriguingly, the pulse pattern was not constant. It evolved gradually as 3I Atlas moved through the solar system, varying in rhythm and intensity. Then, an event occurred that many scientists now regard as pivotal. Within hours of Webb's infrared instruments locking onto the object, the pulse sequence altered.